ground deformation is near the Norris Geyser Basin, the hottest and most unstable thermal basin in the park.
Norris Geyser Basin is one of the most dynamic of the hydrothermal areas at Yellowstone. It's always changing. We're always noticing new things that are happening.
Just a few years ago, satellite images showed Yellowstone's greatest rise in this area. Recently, however, it's reversed its direction and is now subsiding.
It's not actually within the Yellowstone caldera, yet it's one of the highest temperature thermal areas in the park. And it is possible that there is some magma extending to the north beneath that region.
The source of the basin's volatility could be magma, or another key component to volcanic activity, earthquakes.
The earthquakes are essentially the heartbeat of the system, are an integral part of the active, if you wish, mountain building and volcanism of Yellowstone.
Like smoke and fire, volcanoes and earthquakes go hand in hand. The pressure from the magma, which can explode into a volcano, also forces the ground to shift, causing earthquakes. They can be the telltale signs of an impending eruption.
The two main precursors to a volcanic eruption, seismicity and ground deformation, are very carefully monitored in Yellowstone.
In this computer model, each red dot represents an earthquake. Typically, hundreds of earthquakes are detected across the park each year. In recent years, the greatest earthquake activity has been centered under two areas of the park.
Well, you can see we have earthquakes that are concentrated on the north side of Yellowstone, coming down through the park, and then out extending on the east side of the Teton Fault right here.
What concerns geologists is when a center of earthquake activity overlaps an area of shifting terrain. At the Norris Geyser Basin, that seems to be what's happening. There are dozens of fault lines at this spot.
That's very critical because if magma is starting to move up, we would expect to see a bulging in an area and associated earthquakes as the ground starts to crack.
The fear is faults that make up the earthquake zone could crack under pressure from the magma below, releasing an eruption. Geologists are also watching the park's geysers, hot springs, and mud pots, looking for drastic changes in temperatures and chemical content. Anything that might indicate a major movement of magma. At the moment, geologists do not believe an eruption is imminent. But if the water temperatures were to rise, the ground begin to swell, or there were an increase in earthquake activity, another Yellowstone eruption could be building.
I think that we are smart enough as geoscientists now that we would probably have weeks to perhaps months of indicators before anything like that would occur.
However, predicting the precise timing of an eruption is far from simple. Scientists have been fooled in the past.
We've seen it in Yellowstone. There's bulging, there's vibrations, there's increased seismicity. There's all the things one would expect and go, oh, uh-oh, we're in trouble. And then, nothing.
Supervolcanoes like Yellowstone could explode suddenly, without warning, without seismic movement signaled as earthquakes. When we think of an explosive volcanic eruption, we imagine it being preceded by earthquakes, by ground swelling, by the mountain venting some hot gas, perhaps even some lava. These are the signs we look for in the inexact science of volcanic predictions. But two research papers, published on the very same day this year, say that predicting supervolcano eruptions is even more difficult than predicting the eruptions of regular volcanoes. More on that in a moment. But first, do the events in Yellowstone earlier this year demonstrate changes that may be building toward an eruption?
We did have an earthquake of 4.8 magnitude. Now that is the largest we've had in Yellowstone in over 30 years.
And a couple of months later shuts down a road that's melted because of increased ground temperature. People start to get edgy about an impending eruption. I went to Yellowstone recently, and geothermal activity is everywhere. A reminder that you're on top of a super caldera and magma dome, the largest on Earth.
Frankly, we are just a few miles above some really hot magma. That magma serves as the heat that fuels the geysers and hot springs and fumaroles in the park. It's that engine that allows for the unique things that we see here in Yellowstone.
This is what the melted road looks like 2 months later. Yellowstone spokesman at the time said the road had turned to soup, and that was widely reported, even in the mainstream media. But when I spoke to a ranger there, she dismissed it as simply a bad asphalt job.
That was closed due to melting, the heat?
No, it has nothing to do with that. That was just a couple of days. It was the asphalt was soft. It was actually a bad asphalt job that they had done the summer previous to that.
Okay.
And that combined with the intensity of the sun in the middle of the summer, and that it was in a hydrothermal area, that it just got soft.
Oh, okay.
And they just had to replace it.
So it had nothing to do with an increase in geothermal activity in that area, the ground being hotter, it was just the asphalt, wasn't it?
The asphalt, yeah, it was the combination of those things in that particular spot.
I hadn't visited Firehole Lake Drive when I spoke to her, or I would have challenged what she told me. 2 months later, the road still doesn't look good. But more importantly, Yellowstone spokesman told the press at the time that people needed to stay away from the road because there was a high danger of stepping on seemingly solid soil into severely hot water. Contrary to what she said, Firehole Lake is an active geothermal area, and you can see that the road deteriorates as it comes into proximity to geothermal features. But it's what we've come to expect from government employees at every level: fear for their job if controversy erupts, and contempt for the public's right to know. If it was just a bad asphalt job heated up by the sun rather than increased ground temperature, then why are there other melted paved areas that they've just fenced off rather than try to fix? My suspicion is that the spots are so hot at the moment that they can't fix them. Ground temperature goes up and down with seismic activity in the park.
We see between 1,000 and 3,000 earthquakes a year in Yellowstone. Most of them are so small, nobody ever feels them.
Swarms of small earthquakes that you can't even feel can cause the ground to go through major changes. Look at this area that was once a forest. The ground was a hospitable environment for trees to grow for a long period of time. Then in 1978, swarms of small earthquakes caused the ground in this area to rise to 200 degrees Fahrenheit. It wasn't the quakes, but the heat that killed the trees. So while we may be heading into another period of increased activity in Yellowstone, it's far from the largest activity we've seen since it became a park. Of course, everyone will tell you that it's not if, but when the super caldera blows up.
Yellowstone's supervolcano has been hit by a series of earthquakes, with more 30 recorded since June 12. The latest was recorded on Monday, June 19, with a magnitude 3 earthquake striking 8.6 miles north-northeast of West Yellowstone, Montana. The swarm began last week, and on June 15 saw a magnitude 4.5 earthquake take place in Yellowstone National Park. The epicenter of the shock was located in Yellowstone National Park, 8 miles north-northeast of the town of West Yellowstone, Montana. Scientists from the University of Utah, which monitors Yellowstone Volcano, said in a statement. The earthquake was reportedly felt in the towns of West Yellowstone and Gardner, Montana, in Yellowstone National Park, and elsewhere in the surrounding region. This earthquake was the largest to have hit Yellowstone since March 30, 2014, when a magnitude 4.8 earthquake was recorded 18 miles to the east, near the Norris-Giza Basin. The 4.5 earthquake is part of an energetic sequence of earthquakes in the same area that began on June 12, the statement continued. This sequence has included approximately 30 earthquakes of magnitude 2 and larger and 4 earthquakes of magnitude 3 and larger, including today's magnitude 4.5 event. As of June 16, 235 events had been recorded. Most of these ranged in the magnitude of 0 to 1, with 5 less than 0. The University of Utah is part of the Yellowstone Volcano Observatory, YVO, which monitors volcanic and earthquake activity in Yellowstone National Park. Seismic activity at volcanoes can signal an eruption is due to take place, although predicting exactly when a volcano will erupt is